Good morning, students. Once again, this is your science teacher, Mr. James. Are you excited for our new lesson? Great. Before we start, I want you to get the following materials. First, your science textbook, your science workbook, your pen, and your earphone. Before we start with our new lesson, let's have a quick review in our previous lesson. Do you still remember the title of our lesson last week? Great. Tides. What are tides? The tide cycle and the sun's role. The moon exerts a gravitational pull on the earth that causes the oceans to rise and fall. The moon's gravitational pull causes the ocean, to bulge. Each of these bulges causes a high tides, and at the same time, low tides occurs between two bulges. Spring tides. So remember, when the earth, moon, and sun are orbiting in a linear arrangement, the moon is in either the new or full stage, with the sun and moon pulling together on the water. Tides are increased, called a spring tide. So remember, spring tide comes from an old English word, springen, meaning to jump. Okay, remember, spring tides occurs when the earth, sun, and moon are aligned. Spring tides occurs during new moon and full moon phases. They are called spring tides because they seem to spring up with a surge of water, and they occur twice a month during full and new moons. Okay? Neap tides. At quarter phases, the moon pulls opposite and equal to the sun, resulting in a lower tides called neap tide. Okay, remember, neap tides occur when the sun and moon are aligned at right angles to one another. Neap tides occur during quarter moon phases. Also occur twice a month when the moon is in its first and third quarters, half moons.
What causes tides? Tides are the rise and fall of sea levels caused by three items: gravitational force of the moon, the sun, and the rotation of the earth. Gravity is the force that pulls everything in the universe towards everything else. Even though the moon is much smaller than the sun, the moon's pull has a much more pronounced effect on the Earth's ocean because it is closer than the sun. The moon exerts around 2.5 times more force than the sun. On the side of the Earth that's facing the moon, the pull of gravity causes oceans to bulge outward. On the other side of the Earth, the moon's pull on the solid ground causes the oceans to bulge there. The Earth rotates on its axis, so this bulge is constantly changing location. The moon thus tends to stretch the Earth slightly along the line connecting the Earth and the moon. The solid Earth deforms a bit, but the ocean water, being fluid, is free to move much more in response to the tidal force. Where the bulge is bigger, it's high tide. Where the water doesn't bulge, it's low tide. In this picture, you can see the difference between high and low tide. The moon's orbit around the Earth also causes tidal changes. Most places get 2 high tides and 2 low tides each day. Approximately twice a month, around new moon and full moon, when the sun, moon, and Earth form a line, the tidal force due to this alignment is at its maximum, and the tide's range is also at its maximum. This is called spring tide. When the moon is at first quarter or third quarter, the sun and moon are separated by 90 degrees, and the solar tidal force cancels the moon's tidal force. At these points in the lunar cycle, the tide's range is at its minimum. This is called neap tides.
The title of our lesson for this week is Earth's Moon. I want you to open your book on page 503. Objective. After this lesson, students will gather and synthesize information to describe the features and characteristics of the moon. Vocabulary words. After this lesson, you will understand the meaning of the following words. First, Maria, meteoroid, crater. Between 1969 and 1972, 6 spaceships landed on the lunar surface. So when we say lunar, it means moon. The astronauts brought back soil and rock samples. Scientists have used modern methods to study these samples. Because of the Apollo missions, we have learned a great deal about the moon. No astronauts have visited the moon since 1972. There is talk of someday returning, but as of now, there is no concrete plans. What is the moon like? For thousands of years, people could see the moon, but didn't know much about it. Galileo's observations were some of the first to show details on the moon's surface. Scientists have learned more about the moon's features. The moon is dry and airless and has a irregular surface. Compared to Earth, the moon is small and has large variation in its surface temperature. Surface features. We all know what the moon looks like. It's always looked the same during our lifetime. In fact, the moon has looked the same to every person who has looked up at it for all time. The moon has many unusual structures, including maria, craters, and highlands. When you look at the moon from Earth, you notice dark and light areas. The maria are dark, solid, flat areas of lava. Maria covers around 16% of the moon's surface, mostly on the near side. The maria formed about 3 to 4 billion years ago, when the moon was continually bombarded by meteorites. The landscape of the moon, its surface features, is very different from Earth. The lunar landscape is covered by craters caused by asteroids. When we say asteroids, these are chunks of rocks or dust from space. The craters are bowl-shaped basins on the moon's surface. So these are examples of craters from the moon. The lighter parts of the moon are called highlands. Some of the light-colored features you can see on the moon's surface are called highlands or mountains. The rock looks light because it reflects more of the sun's light. The peaks of the lunar highlands and the rims of the craters cast dark shadows. The highlands cover most of the moon's surface. Size and density. The moon is Earth's only natural satellite. The moon is about 1/4 the size of Earth. The moon is 3,476 kilometers across, a little less than the distance across the United States. The gravity on the moon is only 1/6 as strong as it is on Earth. If you weigh 120 pounds on Earth, you would only weigh 20 pounds on the moon. You can jump 6 times as high on the moon as you can on Earth. Temperature. The moon has no atmosphere. With no atmosphere, the moon is not protected from extreme temperatures. At the moon's equator, Temperatures ranged from a torrid 130 degrees Celsius in a direct sunlight to a frigid negative 170 degrees Celsius at night. Water. For many years, people thought the moon had no water except for a small amounts of ice. In 2009, scientists using data from several space probes determined that a thin layer of water exists in the moon's soil. The total amount of water is very small, but it is found in many places on the moon's surface. Maybe you're wondering what is a space probe. So when we say space probe, it's a robotic spacecraft that does not orbit Earth, but instead explores further into outer space. A space probe may approach the moon, travel through interplanetary space, fly by, orbit, or land on other planetary bodies. This is an example of space probe, Luna 2. Origins of the moon. Scientists have suggested many possible theories for how the moon formed. The theory that seems to best fit the evidence is called the collision ring theory. About 4.5 billion years ago, when Earth was very young, the solar system was full of rocky debris. Scientists theorized that a planet-sized object collided with Earth. Material from the object and Earth's outer layers was ejected into orbit around Earth, where it formed a ring. Gravity caused this material to clump together to form the moon. Vocabulary words. So first word is Maria. So when you say Maria, it's a dark flat areas on the moon's surface formed from huge ancient lava flow. Meteoroid. A chunk of rock or dust in space, generally smaller than an asteroid. Crater. A large round pit caused by the impact of meteoroid. Let's summarize our lesson. So the title of our lesson is Earth's Moon. What is the moon like? So we discussed surface features, size and density, temperature, water, and origins of the moon.
The moon was formed about 4.5 billion years ago, when, according to one theory, the Earth slammed into another early planet. Debris from this collision began to orbit Earth and accumulated, forming today's moon. The moon is the fifth largest natural satellite in the solar system, with a diameter just under the width of China. It's composed of an iron-rich core, plus a mantle and crust containing minerals made of magnesium, oxygen, and silicon. The moon's surface was once geologically active and covered in an ocean of magma. But today, apart from traces of water ice, the surface is completely covered in dust and rocky debris. Countless craters dot the moon's surface, each formed by objects such as meteoroids, comets, and asteroids crashing onto the moon. The largest crater, the South Pole Aitken Basin, spans across a quarter of the moon's surface and is nearly deep enough to fit Mount Everest inside. The moon orbits our planet at an average distance of 30 Earths. It rotates at the same rate that it revolves. So as it revolves around our planet, the same side of the moon faces the Earth at all times. From the Earth's surface, we can observe 8 distinct, traditionally recognized stages of the moon's illumination. Called lunar phases, they have been observed for thousands of years and even provided the basis for the earliest calendars. For most of human history, the moon could only be studied from afar. But on July 20th, 1969, humans were able to close that distance with the American spaceflight mission Apollo 11.
That's one small step for man, one giant leap for mankind.
It placed humans on the moon for the very first time, bringing our understanding of Earth's only natural satellite.
Thank you for watching and listening in our video. I hope you enjoy and you learn something from this video. Thank you.